Hello dear friends, this is Sonigra, and today in the subject of mechanical drafting we will discuss a chapter titled as projections and sections of solids. The objectives of today's presentation is to draw various views of basic solids based on given condition, and other objectives are to understand various positions of cutting plane and to draw various views, that is front view, top view and side view, and also true shape of the sections as per given position of the solid. Now this is first example. A hexagonal prism 30 mm sides and 80 mm height has its hexagonal base in vertical plane. A cutting plane passes through a point on the axis at 60 mm from VP and inclined at 60 degree to vertical plane. Draw projections, sectional views and a true shape of the section. Here hexagonal prism is given and given condition is little bit different. Here it is given that its one of the face is in vertical plane and the axis makes an angle of 60 degree with VP. Hence in the first step we have to draw a hexagonal face in front view, means above XY line as per first angle projection method. So this is the brief data of the given problem. So whenever you solve any problem, first you should write the brief data and think about the given condition. Here base is on vertical plane, hence first we draw XY line that represents intersection of HP and VP, and draw a hexagon above XY line like this. Two sides parallel to vertical plane and above XY line, and then draw its axis. Height of this prism is given as 80 mm, side length is 30 mm. So at a height of 80 mm below XY line, mark a point, and by taking projections from the side of this hexagon like this, complete a rectangle. So this rectangle represents the top view of this rectangular prism as this hexagonal prism, and this hexagon shows the front view of this hexagonal prism. Now these are the projection lines. This upper edge, these two edges will be visible. So from these two edges draw lines. So these two lines represents this upper edge and these lower edges will not be visible, hence here hidden lines are there. So two lines are there, solid line and hidden line, and priority should be given to the solid line. Now it is given that a cutting plane which is at a distance of 60 mm on the axis. So from this axis or from this vertical plane at a distance of 60 mm on this axis, mark a point over here, and from this point draw a line. Mark here a point, and from this point draw a line which makes an angle of 60 degree with XY line like this. So this is a cutting plane line and this is the position of cutting plane on the axis. Now this portion is removed portion. You can see here this is removed portion, cut portion. So this will cut, and from this point how this cut portion will appear in the front view. So for that, from this point draw this one, draw straight vertical line, and this vertical line would represent this cut portion. So if you cut it over here, this will be the remaining portion for this hexagonal prism. This is sectional front view, this is top view, and how to draw true shape. Let me draw its true shape and other views. So up to this step we have drawn a hexagon above XY line, and this is a cutting plane. So let me draw this cutting plane like this. Two small days, one long days like this. It is a cutting plane, you can see here, and remaining portion is this one, is here represented by this blue colored pen. This is remaining portion, and this lower portion is removed portion. so it is cut one. So here lines would be there from this end to this end to this end, and from here from this end to this end. So this portion is removed. You can trim that portion as well, as it's not needed portion, for better understanding. Now pick up the points of intersection between these projection lines or these edges and cutting plane. So for that, let me name the end points. So here point number 1, 2, 3, 4, 5 and 6, and of course it's a front view, so dash would be there. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, and appropriately here 1, 2, 3, 4, 5 and 6 points are there. Now on one point, here point number 1 is there, so intersection of this generator or projection line from 1 and cutting plane is here. So P1 point is here, from 2 P2 point is here, from 3 P3 point is here. Here 2 points would be there, P3 and P4, and here P6 point would be there. Right. 2 point are here, 2 here, 1 here. Now I didn't locate the position of these points in the front view. So for that, from here draw straight vertical line, from here straight vertical line, and from here straight vertical line, like this. That is projection line. So after cutting this would be as represented by this green colored would be the cutting portion, like this. Now how to draw this true shape of this section? This is the sectional front view, as we know. Now how to draw the true shape of this section? So for that, locate each points in this front view. Say P1 point is here, P1 is at 1 dash, P2 is here, P3 is here, P4 is here, and P6 is here. So to locate the true shape of this section from each point, P1, P2, P3, P4, in the top view, draw lines like this, such that these lines are perpendicular to this cutting plane line, that is projection line, right? These lines are perpendicular to this line. This angle is 90 degree. Now measure the distance of respective points in the front view from XY line. Measure this distance, XY line to P1 point. Measure this distance, put it over here on P1, draw an arc. So here would be 1 point, right? Locate here point number 1, or say P1 point. P1 point is here. Similarly, point number P2, XY line to P2, measure this distance, XY line to P2. On P2, mark a arc over here. So here is point number P2, somewhere here, point number P2. Then P3 at the same distance. So here also we can mark a point P3 at the similar distance, P3. Then P4 is from here, XY line to P4, this is the distance, measure this distance, XY line to P4 and XY line to P6, both are same. So from P4, 1 arc over here, P6, 1 arc over here, and mark those points over here. So here is P6 and here is P4, and join all these 5 points with the straight line in sequence, which it represents the true shape of this cut portion. If this hexagonal prism is cut at this angle, this would be the true shape of the cut portion, and draw section lines in this cut portion, which makes an angle of 45 degree with this cutting plane line, not XY line. You should take care about this also. And right here, the name of view, it's a true shape. This is front view and the rest all, and this is top view. So you can erase these lines as they are not needed for clarity of the drawing. So this is the solution of this problem. I hope it's clear to you. Now next problem. Example number 2. The given data is like this. A right circular cylinder is cut as shown in diagram. Draw sectional top view and true shape of the section. Here 550 is written. Nothing is mentioned over here. And we have to assume that this is a cutting portion, this is cutting portion, and this angle is 45 degree. So if this angle is 45 degree, this is axis, so this distance is 25, this distance would be obviously 25, and this height also would be 25. So total height would be 25 plus 25, 50 millimeter, and width would be 50 millimeter. Only from this figure we have to assume this data. Now how to briefly write this problem. So for that, cylinder is given 50 by 50. So first of all, draw XY line and draw a circle below XY line of diameter 50 millimeter. Draw its axis, vertical axis and horizontal axis, and from these endpoints draw projection lines, and at a height of 50 millimeter draw a rectangle having height 50 and width 50. So this rectangle is to be converted into square, and this is the cut portion. Line at an angle of 45 degree from this end and line at an angle of 45 degree from this end. So this is the cut portion. Now we have to draw the views of this cylinder, true shape or cut portion of this cylinder. So for that, let me draw this problem. We have drawn up to this step. Now to draw further, let me divide this circle into equal number of parts as it is done over here. This circle is divided into 8 equal parts. So name the endpoints. So we start from here. Point number 1, 2, 3, 4, 5, 6, 7 and 8. Equal division of the circle, and this is drawn. Now take projections from this top view. Draw here meter line, as we know how to draw the meter line. Line at an angle of 45 degree to any side of the top view, and from here draw projection lines like this from point number 1, 2, 3, 4, 5 and 6, and when it cuts the meter line, from that draw vertical lines, and here you can draw the side view of this cylinder like this, and from here horizontal lines like this. So this view represents the side view of this given cylinder. Now how to draw the true shape and cut portion of this cylinder. So for that, let me pick up, assume that this is a full cylinder, right, and this is the cut portion only, as we represent it here with just a red color, just to understand what is the cutting plane. Only this is the cutting plane. So find out the points of intersection between this cutting plane and these generators. So here generator 1 is there, so here point number P1 would be there. Here generator 8 is there, let me draw that generator over here also. Generator from 2 and 8, this is that generator. An intersection of this generator and cutting plane is here, so that is point number P2 and point number P8. 2 points would be here. Similarly here 3 and 7 are there, so point number P3 and point number P7 would be over here. So we have identified 5 points, P1, P2, P3, P7 and P8, and draw vertical lines from here, P1 to here, P3 to here. So this all portion is cut portion. So in all this region, from vertical line from point P1, P3 and P7, this is the cut portion. So in this region we have to erase these internal lines and then draw section lines. So it represents the sectional top view of this cut cylinder, and here 2 cutting planes are there and both are alike, so no need to draw the bottom one. Bottom one is overlapped by this upper one. You can write here the name of view, it's a sectional top view. Now what's about the true shape of this section? So for that, the same procedure we have to repeat. Identify the points P1, P2, P3, P7 and P8 over here, and from those points draw lines perpendicular to the cutting plane line from all these points P1, P2, P3, P7 and P8 like this. These lines are drawn in such a way that the line makes an angle of 90 degree with this cutting plane line. Now measure the distance of each point in the top view. So here is point number P1, P2, P3, P7 and P8 points are there. So measure the distance of point P1 from XY line, measure this distance. From P1 draw an arc, and that arc will cut over here. So here is point number P1, right? Then measure the distance of P2 to XY line. This is the P2 to XY line, this distance. From P2 draw an arc over here. So point number P2 is here. Here is point number P2. Now P3, XY line to P3, measure this distance. On P3 draw an arc. So here point number P3 is there. Similarly P7, XY line to P7, it's quite close. So XY line to P7 over here. Here is point number P7. Similarly P8, little bit near this one, draw an arc. So here is point number P8. Now join all these points P1, P2, P3, P6, P7 and P8 with a smooth curve like this. Because it's a cylinder, smooth curve would be there. If it is prism or pyramid, smooth curve may not be there. So this smooth curve would be like parabolic shape, and here straight line would be there, which is of course the diagonal of this cylinder, and erase these internal lines which are not necessary, and in this portion, in this parabola, draw section lines